Lesson 5.4, Factor and Solve Polynomial Equations, under the subheading, Factoring Higher Degree Polynomials. At this point, we've learned everything we need to know about the process of factoring. We're just going to apply some of the prior concepts that we've learned to higher degree polynomials. For example, let's look at this first one, 16x to the fourth minus 81. We've definitely seen things like 16x squared minus 81, and we're able to continue with that based on difference of two squares. There's nothing different about that process than this process. I still notice it's a binomial, which means it's got to be one of the patterns if I can continue. I should also note that there's no common monomial factor, so I can't start by factoring something out. However, since it's a binomial, I look to check for the patterns. Since it is the difference, that means I could have the difference of two squares or the difference of two cubes. Right away, when I look at these numbers, I know that they are the difference of two squares because 16x to the fourth is a square and 81 is also a square. So I take the square root of the first term, which would be 4x squared, minus the square root of the second term, and then I take the square root of the first term plus the square root of the second term. The only difference between what we did before and what we do now is that I can possibly have the opportunity to continue. If I take a look at this first set of parentheses, I notice it is still a binomial, and when I really look at it, they're still both perfect squares, which means I can continue with the difference of two squares pattern. The square root of the first, which would be 2x, plus the square root of the second, the square root of the first, minus the square root of the second. That all comes from this first binomial. When I look at the second binomial, they are still both perfect squares. But the one red flag that should jump out is the addition sign in between. Because of the addition sign, I cannot apply the difference of two squares pattern because, as you should notice by the heading, it is the difference of two squares pattern. It does not work with a sum, which means I cannot continue to factor that binomial, and it stays 4x squared plus 9. This is my final answer. Let's look at a second example. Let's say we have 2p to the 8th plus 10p to the 5th plus 12p squared. Well, I have a trinomial here. When I look at it, I want to see, is there a common monomial factor that I can pull out? And that answer is yes. Looking at my coefficients, I can factor out a 2. Looking at my variables, I can factor out a p squared. That would leave me with p to the 6th, because remember, when you divide p to the 8th, and you're dividing out a p squared, remember our rule. When you divide like bases, you subtract the exponents. So when I divide out that p squared, I'm left with p to the 6th plus 5p to the 3rd plus 6. Looking at this, I now have a trinomial. The only difference between what we saw in Chapter 4 would be it looked like this, p squared plus 5p plus 6. Now when I'm looking at it, I have a degree 6. As long as the degree on your first term and the degree on your second term, okay, as long as the degree on your second term is half of the degree on your first term, you are good to go with the same method we've always used. Since 3 is half of 6, I can continue going using the same method we went with in Chapter 4. If this was an 8 and a 4, I would be good to go. If this was a 10 and a 5, I would be good to go. If we had a 10 and a 4, I could not continue. It has to be half of that first term. If I use the same principles applied in Chapter 4 with a trinomial and a leading coefficient of 1, I simply have to think of two numbers that multiply to give me 6, add to give me 5, and the rest will fall in place. Those numbers would be positive 2 and positive 3. So whereas before in Chapter 2 we would say p plus 2 and p plus 3, okay, I can't quite do that because that's not going to give me the exponents I need. So instead of p plus 2 and p plus 3, it's going to be p cubed plus 2 and p cubed plus 3. In my final step, I cannot forget to bring down this monomial term that we factored out in the first place, which is 2p squared. This is my final answer.